Welcome to Structural Analysis 2 video series. Unit number 5th, Approximate Analysis of Multi-Storied Frame. This one is the second part. And in that, we are going for the numerical on analysis of a frame by Portal method, part 1. The numerical statement as follows. Determine the approximate value of a moment, shear, and axial forces in the member of a frame loaded and supported as shown in a figure using Portal method of analysis. So here the some loads are acting on the frame. One is of a 50 kilonewton at the first floor, and second is a 25 kilonewton on second floor level. The height of a columns, first column is of a 4.5 meter and the second column is of a 3 meter, and the height of distance between the column or spacing of a column 4.5 meter, and then the next is 6 meter spacing. So in on the frame, we have to solve this frame by the Portal method. Now here we have to find out moment, uh, and shear force and axial force. So if we consider the any joint uh, between the joint of a column or beam, there will be two forces acting. One is shear force and one is axial force along the member. So these two forces are there, and also we have to show these two forces, and also we have to draw the bending moment diagram for the beam and also the for the column. So this thing we have to do here. Assume point of a contraflexure at the center of a beam and column. So these are the point of contraflexure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the point of contraflexure which are shown at the mid of the beam and at the midpoint of a column. Now let's consider upper story of a releasing the frame from node 3, 4, 5. So let release frame from node 3, 4, 5 and draw consider only upper part. So when we considering releasing from 3, 4, so height of this part is half of a column height. The column height is 3, so this height will be 3.5 meter. So for this 1.5 meter, and we have to consider this 1.5 meter length for the further calculation. And the distance between, when we talking about the joint, we have to consider only when we talking about G joint, then we have to consider this much part. So this height will be 1.5 half of column, and this height will be, this length will be half of this 4.5. So this length we have to consider when we talking about the joint G, and likewise we have to consider other joints. Consider upper story and releasing the frame from node 3, 4, 5. The horizontal shear is divided among all the column. On the basis of that, each interior column take twice as much of exterior column. So exterior column taking H shear force. So and our assumption is that interior column take twice of that exterior column. So it become 2H. And there is a point load of 25 kilonewton. So we separate the frame from node 3, 4, 5. Now consider summation fx. uh, so let's consider this plus h toward the uh, right left hand side positive, and toward the right hand side minus sign, and according to the plus h, then the plus 2h, then the plus h, and minus 25, it become plus 25 toward the right hand side. By solving that, we having h is equal to 6.25 kilonewton. So putting that h value here, we having 6.25, then here it is 2h, so become twice 12.5, and here is h, so it becomes 6.25, and there is a point load of 25 kilonewton. Okay, so we having the shear forces acting at the mid of the column or horizontal shear. Now consider each joint, consider joint G, and find out the forces acting at the uh, at the joint. Let's draw the FBD for joint G and then the joint H and then the last one joint I. Okay, and then to find out the forces. Let take consider first one is a G joint. So now the joint G, where H3, which is a 6.25 as calculated earlier, and let us assume V3 acting away from the joint. There is a tension in the column. Let us assume that. Then there is a V1 which is acting upward direction and H1 which is acting toward the joint, and there is a 25 kilonewton force acting at the G. Now do the summation Fx is equal to 0. Here we taken right as a positive and left as a right side as a negative, and arrow toward the left side positive. So let consider plus h1, then plus h plus 6.25, and this one is a minus 25 is equal to 0. So we have h1 is equal to 18.75 kilonewton. Then take moment about the G. Take clockwise as a minus and anti-clockwise as a positive sign. So taking moment about G. So when we taking moment about G, the forces, axial forces, that means H1, V3, and 25 kilonewton, which is passing through the G. So their moment will be 0. Only moment of V1 and moment of this H3 we have to consider. So uh, so and so let take that one. uh, so V1 rotate about G in a anti-clockwise sense. So V1 into 2.5 positive, and next is this H3 rotate in clockwise sense about G. So minus 6.25 into the lever arm is 1.5 is equal to 0. So we have V1 is equal to 4.16 kilonewton positive. So our assumption is correct, upward. Now do the summation Fy. Upward, take upward force positive, and downward it has a negative. So vertical forces are 2 plus V1 and minus V3 is equal to 0. V1 we know from the previous calculation 4.16. Putting here we will get V3 is equal to 4.16 kilonewton. Now let's consider next joint, H joint. Now whatever the forces here, you have to act them in opposite sense on adjoining structure, or on for the H joint. H1 is acting toward the left side, so you have to consider here toward the right side, and this H V1 acting up, so here we have to consider down side. So let first also the other joint, at this joint H4 we know, which is acting toward the, we assume earlier, toward the left side at 12.5 kilonewton, and let consider there is a V4 acting toward the member. uh, then for this joint let consider H4 H2 acting toward the joint, and V2 acting in upward direction. These are the unknowns. So let do first summation Fx. Let consider right side positive and left side the negative sign convention. So horizontal forces are H2 minus H2, then plus 18.75, next is minus 12.50 is equal to 0. So we will get H2 is equal to 6.25 kilonewton, positive sign. So whatever the sign we assume which is correct. Then take a moment about H. Clockwise is negative, anti-clockwise is positive. So when we taking a moment about H, that means the forces which is along the member, there are how many forces along the member? H1, H2 and V4, those are along the member, their moment will be 0. Only the moment of perpendicular forces, that means V2, V1 and H4, these moment will only we have to take about H. So let's take one by one. First is uh, this v1 which is rotate about h in a anti-clockwise sense, so plus, and lever arm is 2.5, so 4.16 into 2.25 positive. The next is v2. Now see, the v2 is rotate about h in a v2 rotate about h in a anti-clockwise sense, so, and lever arm is 3, so v2 into 3, v2 into 3 plus v2 into 3. Then next is forces, this 12.5 which is rotate about h in a clockwise sense, so, and lever arm is 1.5, so minus 12.5 into 1.5 is equal to 0. So v2 is equal to, by solving we have v2 is equal to 3.13 kilonewton positive, so we assume up, so up is correct one. Then do the summation fy to find out this v4. So summation fy, upward is positive, downward is negative, so vertical forces we have to add plus v4 minus 4.16, and this v2 plus v3 v2, and value we know 3.13 is equal to 0, so we have v4 is equal to 1.03 kilonewton positive. That means the upward assumption is correct. Now let's consider joint I. Now here we consider whatever the sign here we taken, the opposite sign we have to take on adjacent member or adjacent joint for the same joint, but for the uh, I joint, these are the for edge joint, so take in opposite sense. After that, here we don't know, here we know the h5 6.25 toward the left hand side, v5 we don't know, let consider which is acting toward the joint. Now let's do the summation fy. Only v5 is unknown here, summation fy is equal to 0, up plus down minus, so this one is a minus 3.13, and this one is a plus v5 is equal to 0, so we have v5 is equal to 3.13 kilonewton. So now we having all axial forces and shear forces acting on the joint. Okay, now consider next portion which is below this next joint. Now there, when we are showing the forces, this should be shown in opposite sense. Now this v2 acting down, so for the member just below this, there we have to show the in upward direction, and h3 is acting toward the uh, left hand side, we have to show toward the right hand side. So this care we have to take when we consider the next part. Let's consider the next part of a frame. So in consider the lower story and releasing the frame from a node 8, 9, 10. The horizontal shear is divided among the all the column on the basis of each interior column take twice as much as the exterior column. Now let consider the lower part or the node 8, 9, 10, and the interior column taking 2h, exterior taking h. Then again here now we have to take 50 kilonewton force because we are considering node 8, 9, 10. This one is 8, 9, 10. Now doing summation fx, we can find out the value of h. So right is positive and left is negative according to that. Let's take this one is a minus. If these are the sign convention, we must take minus h, then minus 2h, then minus h, and this one for this 2 plus it become this side minus minus. So when we solve, we have the h is equal to 18.75 kilonewton. Okay, so we know the h value of h now. Put the value of h here, and then consider the joint f, then consider joint e, and then consider joint d, and then find out the axial forces acting on it. Okay, so the remaining part will be resumed in the next video. Thank you.